Hi, today is day 16, Tuesday, April 14th, and I wanted to explain to you section 10.2, cube roots and functions. Some of these video clips are also available on Algebra Nation in case you wanted another take on it. So I will add that to the list. All right, so here are your notes. And so today we're talking about cube roots. Yesterday was square roots. And so if you want to take a quick picture of the notes and freeze it and write those down, today you do not have to submit your notes. I am going to attach a homework assignment that I would like for you to do. You can either print it or just copy it down and then submit it to me. Okay, so we're talking about cube roots once again. Now with cube roots, I can put a negative number in there. So because when I take the cube root of it, it's actually fine. Just think about it. A negative times a negative times a negative just gets me a negative number. So we can do negative numbers in cube roots, and you can check that on your calculator. So remember, to get the cube root button, there it is right above the 0. Right here you'll see it says cube root, and to get that we have to press the second and that will tell us the cube root of a number. So if you were writing this using exponents, this would be x to the 1/3 power. Okay, so I'm going to fill in my chart just so I can see what a basic graph looks like. When I plug in -8, 8 negative, and I'm going to cube root it, I get -2. 1 negative, cube root it, whoops, and I get -1. 0 cube rooted, you get 0. 1 cube rooted, in case you're not sure, 1 cube root, 1, and then 8 cube root is going to get me 2. So if I had to graph this, remember once again, we're going to try to just look at the parent function so we don't have to graph all of these if we remember kind of what this parent function looks like. So I'm just going to go by twos here. -2, -4, -6, -8. So at -8, and this is going to be -2. At -8, I have -2. At -1, I have -1, 0, 1, 1. And then 8, 2, 4, 6, 8 is 2. So cubic functions kind of look like this. Okay, and there's some really nice things about cubic functions. So that's our parent cubic function. And we're gonna answer some questions based on that picture. If we look here, those are arrows on the end. I'm looking at it going, it doesn't really look like arrows. So the domain, so on the X, you see how this thing is gonna keep going out and out like this forever. So our domain is all real numbers. And I noticed that you can write it two ways. I'm okay if you write all real numbers, but if you saw like -infinity to +infinity, that's also a fine way to write that. But I'm okay with all real numbers as well. Either way is fine. And then the range, if you look here, this is, I mean, I kind of made it look like it's going straight out, but it is going up, 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 up slightly. So for range, it is the same thing. It is all real numbers or -infinity to +infinity. So that's kind of nice that when we see these cubic functions, we know that's going to be the domain and range. There's not a whole lot to this. Now the x-intercept, here you can see it's 0. And the y-intercept is also 0. So we're going to look at some transformations. Remember, we don't have to keep graphing everything if we know our transformations. So here's the first problem. I'm going to keep that parent function nearby so I can see. So it's asking what transformation has took place, and we're going to talk about some of these x-intercepts, y-intercepts, and domain and range and stuff. So here, what transformation has taken place to go from here to here? Well, this is in the parentheses. So it has our x-intercept, the domain, sorry, I'm all over the place. Okay, the transformation that took place is a translation, and it has gone left 1. So basically, if I had to take this and shift it left 1, so you can see how my x-intercept would end up being negative, or yeah, sorry, this is done by 2's over 1. So my x-intercept is going to be -1. My y-intercept, I'm going to have to fiddle around with to see exactly what number that goes through. It's not as easy as the last ones. Actually, it would be just as easy, because if I shift this over 1, this guy goes over 1 as well. So my x-intercept is going to be 1. My y-intercept, sorry. Right, if I shifted that over, yes, it's going to go through the y-intercept at 1. Okay, and then my domain, all real numbers, and my range, all real numbers. So if it's cubic, man, I got that under control. I know exactly where this is going to go. Okay, so let's look at this third guy right here. So we're asking, how did it go from the parent function? Well, remember, if it's in parentheses, so now instead of going left 1, this is going left 2 spaces over. So I look at my parent function, and this is moving all the way to over here. So I know my x-intercept is now -2. My y-intercept, we're going to have to talk about that. So if I'm trying to find my y-intercept and I'm going, I don't know exactly where it is. I know it's in between 2 and 3 somewhere, but I don't know where. So we're going to have to try to find out algebraically. So to find that, what I would do is I would plug, remember, if I'm trying to find the y, I can plug 0 in for x. And then all I'm going to do is put 0 plus 2 is 2. So my answer is actually going to look like this. And they've just left their answers like that, saying the y-intercept is the cube root of 2. All right, so to find that, you would just plug 0 in there. Remember, domain and range, all real numbers. Okay, let's look at this one over here. So now it says -4. So I'm taking this parent function and I'm going to basically slide it down 4. So I'm shifting it all the way down here. So I can see the y-intercept has changed. So the y-intercept is going to be 4. The x-intercept, where is it going to go through the x? Well, I don't know exactly where it's going to go through the x. So what I'm going to do, when we had to find the y-intercept before and it wasn't obvious what it was, I plugged 0 in for x. So to now find the x-intercept, I'm going to plug 0 in for y. Remember, h of x is the same thing as y. So to kind of do my work over here, I'm going to put 0 equals the cube root of x minus 4. I'm going to get rid of this and add 4 to both sides. Now the opposite of cube root is cubing, so I would cube both sides. So 4 cubed, whoop, sorry. Oh, my papers are messed up. Let me just move this over. There we go. So where was I? So to cube, I'm just going to do 4 cubed, and I get 64. So 64 equals x. I'm going to go back because that was kind of crazy to me. So if this whole thing got shifted down 4, right, then it would go over all the way over here at 64. It's possible. So I'm going to say my x-intercept is 64. Okay, and then once again, domain and range, all real numbers. Okay, and the last is just like what we did with square roots when we're trying to find the rate of change. I'm going to plug in, if I'm trying to find for the cube root, I'm going to find f of 3 and just plug in that 3. So f of 3 equals, what's the cube root of 3? 1.44, and then find f of 10. So f of 10, same thing. I'm going to put my 10 here and cube root it, and I get, whoops, 2.15. Okay, so remember, what I have to do to find out what the actual rate of change is I have to find the difference between these two, the difference between these two, and then divide them. So sometimes if you do a chart like this, which is probably how I should have written it, it makes it a little bit easier. Okay, so what's the difference between there? 7, what's the difference? 2.15 minus 1.44. I got 0.71 and divide it. Oops. Okay, and I got 0.10. So 0.10, so that is the rate of change between those intervals. All right, that's the end of the lesson. There's a homework assignment that I've attached. I want you to give it a shot. There is another video today of me doing the homework. If you want to, if you're still a little confused and you kind of want to watch me go through it, I'd like for you to attempt it and then just check it. All right, thank you. Have a good day.